What's up guys, welcome to the 17th tutorial in our Pandas course. We just finished learning a bunch of techniques to help us to get various elements from data frames, so now we'll focus on getting properties of data frames, typically by using built-in functions. So some of the stuff we'll learn to fetch will be numerical properties such as maximum, minimum, count, etc. We'll also learn how to get indexes of these properties, and also distribution of values through histograms, which will be value counts. This is just a few of the things that we'll be fetching. I'll show you some of them and kind of leave the rest up to you to explore. So let's head on over to the code now and get started. Alright, so we finished off in section 16 by talking about slicing data frames as per usual. Get yourselves a new cell started up and we'll go from there. I think I'm actually just going to copy the data frame that we used last time into here, just as a quick reference. This is what it's going to look like again. Okay, and there we go. Cool, so just like before, I'm also going to print this out, so anything new we're printing out is going to be displayed underneath. We can see the original data frame to get a feel for how those numbers are actually representative of the overall data frame. Now, once again, I'm working with numbers here. I know we've been working with mostly numbers, even in the series section. That's not to say that some of these operations can't actually be performed on objects or booleans. In fact, we'll try to integrate some of those into this section as well, just because some of the properties will be a bit different. For example, it doesn't really make sense to get the average of a bunch of objects, or even the average of a bunch of true or false values. That's generally why I tend to stick to numbers, just because they're more applicable to most of these functions. Okay, so some of the more basic properties that we might want to get off a data frame will be these numerical properties that help to describe the data it represents, such as the number of items, the maximum, minimum, mean, median, etc. So those can all be fetched through df dot, and then you can find the function that you want. So for example, df dot max, okay, min, mean, median, and so on and so forth. Now, one of the ones we'll want to get will be the count. This will be a very, very common one. Just helps to return exactly the number of elements that are going to be in our data frame. Now, count will return specifically the not a number elements. Let's just put this in a variable called count, and we're just going to go ahead and print that off. So this is going to give us the count broken down into columns. Okay, so even though a lot of the same methods can be applied to data frames as with series, most of them are going to be either column specific or row specific depending on the parameters that we pass in. We can see here that df.count actually doesn't return us all of the counts. It just returns us the count column by column. Again, this is the not a number one, so you might be saying this is 4, but it's actually 3 because we're not counting these values here. If we want to switch things around and get the count row by row, typically we pass in an axis parameter, and we can specify that to be either a 0 or a 1. I think by default it's 0 and returns us the columns. If we want to change that to a 1, it will return us the row by row breakdown. So in this case, 3 not a numbers here, and then 2 not a numbers for the rest of the rows. Okay, so I'm actually just going to make a quick note of that. We want df.count axis like this. It will just go into default to axis equal to 0 and returns you the column counts. Okay, this is actually applicable to most of the functions we'll be looking at here and many of the functions in the next and upcoming tutorials. Generally, if there is an axis parameter, most of the default behaviors will return you the properties or modify things based on the columns, unless you change axis to 1, in which case it will go through things row by row. Now, the axis property is not available to all functions. It's just where you see it, then you can kind of switch things up to get the row instead of the column properties. So the exact same thing happens with maximum and minimum. So if I want to say, I'm just going to say m, okay, it's going to be equal to df.min, for example. Okay, I can also pass in the axis here. So let's say I want the df.min, and I just want to print that out. Okay, this is again going to give me the column by column breakdown rather than the overall data frame breakdown. From there, what I could do, because this is returning me a pandas series, is I could then iterate through the series or just try to find the minimum value within that, which in this case would be 1. Exact same thing for max. I'll just demonstrate that df.max. Okay, let's say I want axis equal to 1. That's going to give me again the row by row breakdown of these values here. Now, of course, with series, there was that describe method, and that helps to return a lot of these properties: the minimum, maximum, count, mean. I think it returned the median, not 100% sure. To get that, we're just going to again use our data frame, and we're going to call the describe function. Okay. Now, describe, you'll note, doesn't have an axis in it. Okay. Because describe will take the properties of the data frame as a whole. So it's no longer just going column by column or row by row. This is the entire data frame, so all rows and all columns. I'm just actually going to print that. You know what? Actually, I'm going to put this in a variable called description, or desc for short. Okay, and we want to see that. We're just going to go ahead and print that guy out. Okay, cool stuff. So you can see that this actually gives us the whole breakdown of the columns. So we're no longer just guessing a single column, we're actually guessing the entire data frame's worth of data here. It's nice that it still does divide it into the respective columns, so we can see we cannot actually rotate this to go row by row. It has to still return that data column by column, but again, it's returning the whole data rather than just that describe based on a single row or column. Of course, if you do want just the row or column, you can fetch that from the data frame using some of these either slicing techniques or just the basic indexing techniques, and then you can use the describe to get the specific parts of that particular series. Okay. Now, I do want to continue on with this maximum and minimum train a little bit, just because we covered a lot of this same stuff in series. That was all the way up in here, our series properties. Basically, any of these can really be applied to our data frames. So I think I'm going to go over the index maximum minimum and the n largest as well. So let's go ahead and get those done down here. Okay, so let's say if we don't want just the maximum value, let's say we want the n maximum, maybe 2 or 3 maximum values, we can get the n largest, or use the n largest function, so df.n largest. Okay, and then we put the number of items that we want. So in this case, we want the top 2. Now note how there's also a columns parameter, and this needs to be filled in. Okay, so the n largest and n smallest will work slightly differently with regards to data frames as with series, in that we have to pick and choose which are the largest based on which columns. Okay, so for example, let's say I want the 2 largest items based on column 2. Okay, so for this, I'm actually going to, I could add the columns parameter name, or I can just put the argument second, and then this will just contain a list of all of the potential columns I wanted. So let's say I wanted column 2, and I'm going to call this just the n most. Okay, because I'll use this for n smallest as well. Okay, so if I want n most, I'm going to go ahead and print that out. Note how n largest didn't have the option for axis. Okay. Now this is pretty interesting. Essentially what this is going to do is it's going to go into column 2. It's going to find the 2 maximum values in column 2, which are 6 and 5, and it will return me the entire rows in which those maximum values exist. Okay, so in this case it returns me row 4 and row 3, and the reason it does that is because it actually sorts them from largest to greatest. So you can see 6 and then 5. And that was row 4 and 3 respectively. Similarly, if I did this with column 3, okay, I should be getting row 1 first, and then row 4 actually. So row 1 and then row 4, because 10 is the greatest, followed by 9, in that order. Okay, indeed I do. Row 1 and then row 4. Okay, so it's always going to find me the maximum values in this column and then return those. Okay, so if the maximum values were distributed a little better, so I'm actually going to replace this with the 9 and this with the 4. So in column 2, row 1, I'm actually going to put the 9 there. Actually, you know what? No, let's put that in row 3. So I'm going to change this to a 9. And then in column 3, row 4, I'm just going to change that to like a 6 or something. Doesn't really matter. Okay, so oops, didn't want to navigate back, but that's fine. We'll go ahead and we'll refresh this. Okay, so this is what our data frame looks like now. You remember that this used to have a 9, this used to be a much smaller number. So now what we're going to do is we're going to get the highest values based in column 2 and column 3 and see how things change. Okay, col 2 and column 3. So now what this is doing is it's getting the highest values across these 2 columns. So essentially, it's going to select the columns, or the rows rather, with the highest values across the two. So in this case, we have a 6 and a 6, so that's going to be not the highest in, well, I guess actually let's start with row 3. So because in row 3, 9 is the highest value, and that's I guess I should say in column 2, 9 is the highest value in row 3, and that's what we're going to be returning. Next up, we have the second highest value being a 6, so we're returning that. Okay, so even though we've entered column 3 in here, it's actually not taking the highest values from column 3. That's because column 2 is first. All right, so we can do a pretty similar thing with the n smallest. For example, n, let's just say n most again, is equal to df.n smallest. Okay, and let's say we want the two smallest values. This time we're going to go across, let's just say col1. Okay, so this really should be returning us the first two rows, again 1 and 2. Not and numbers don't really count, so we can't say they're bigger or smaller than anything else. They're just kind of outside of the realm of comparison. So we are just going to return us our first two rows there. Okay, so next up is going to be the index maximum. And this is actually a very, very useful thing. So very often we'll want to find the index of the maximum or the most highest element. And for that, we're going to use df.idmax or idmin, depending on whether we're finding the, it should actually be idxmax or idxmin. And then again, that depends on whether we're trying to find the maximum or the minimum value. So for example, let's find the index of the maximum. Okay, you can see that once more, we can enter in an axis to determine whether we're trying to find the index of the maximum item in a row or in a column. So we'll start with axis equal to 0. That's the default. Actually, I guess I'll just not enter anything for that. Okay, and we're going to say index is going to be equal to this, and we'll go ahead and print that out. So index. Okay, so we're seeing again, because we have an axis equal to 0 by default, it's going to give us the row or the row label with the maximum value. So in this case, for column 1, you can see the maximum is in row 3. For column 2, we can also see it's row 3. For column 3, we can see it's in row 1. And if we want to kind of flip that around and do it row by row, again, axis equal to 1 is all we need for that. That's going to give us the row by row breakdown and the column which contains the maximum. So again, maximum here, maximum here, maximum here, and this one's, it doesn't really matter because they're both the same, so we're just going to return the first instance of that, so column 2. The same functionality occurs for index minimum, so kind of no point me demonstrating that. I'm just going to, you know what, I'll just show you that the function exists. idxmin, and there we go. So you can go ahead and run that if you want. Should return you the minimum value indexes. Now, once again, we can also get the columns and index names. Actually, with the Pandas series, we couldn't get column names because it didn't make much sense. We didn't have any columns attached to that. We only really had rows. So for that, we would get the index labels. Okay, so to show you what that would look like, we'd get indexes. Let's just call this idx's. This would be equal to the df.index. We can go ahead and print those out. And this just returns us a list of the row labels. Okay, so again, this is an index type variable. If we get the columns, so let's actually, you know what, I don't know why I copied that. We'll just say cols is equal to df.columns. Okay, and then we want to print that out. This is now going to give us the column labels. Okay, note again that it's actually an index type object. Same with the indexes. Okay. So just be careful that you know exactly what you're going to be returning there. It's not just a regular list, although we can access items as if it was just a regular list by their position. We can also get a data type breakdown of our data frame, because remember that individual columns might have completely different data types from one another. Same with individual rows. So if we want to get that, we're just going to again call on our df, and we're going to get the d types. Okay, we're just going to go ahead and, you know what, let's just say d types is equal to this, and we want to print that out. We can probably spell it properly. Okay, and again, it's going to give us a column by column breakdown of these different data types here. In this case, going to be float 64. So generally, the data types are column specific, and so that's why we actually don't get a data type at the bottom like we do with the Pandas series. Okay, that's why there's no one specific data type down there. Okay, now the last thing I wanted to show you guys here is going to be the histogram functionality. And I think that's really cool because we can create and plot histograms without even having to import Matplotlib library or anything. So in order to do that, just going to get rid of that. I'm going to create a histogram. I'm just going to call this hist. And this is going to be the df.hist function. Now the histogram function takes in a lot of different stuff here, okay? So we can really customize how our histogram is going to look. I'm not going to get into the customizations. I just want to show you how to plot some data, okay? So we can pass in the data that we want to plot. Or we can pass in the specific columns that we want. So for example, let's say we want all of the data. We can just call upon the histogram function. That's going to plot everything in these nice little subplots. So you can see that we have the counts of the items, because that's what a histogram is. It's just the number of each item within the data, the number of each unique item. So in this case, I guess we don't have actually any overlap between these. So unique values, unique and unique. We do have overlap across the rows, but we're not doing that. This is by column. So we have unique value in each of these. Okay. In fact, just to demonstrate this, I'm going to have two ones here, just to kind of demonstrate that this is indeed different. Okay, so you can see that I have two ones here and only one 3, and then each of them have only 1. So it's nice that it creates these 3 separate subplots. You can also choose which columns you want to plot by doing something like this. I'm just going to comment that guy out. And I'm going to say that we want only specific columns. Okay, so let's say I only want col 1 and col 2, okay, but not column 3. I can just pass in, should be the list of columns like that. This will just take in, again, the argument of list of columns that we want to display, and it's only going to plot those. Okay, so we're still guessing the error, and that is, all right, this actually should be column, not columns. Okay, there we go. So that's much better. Right, so you can see that we get, again, it's only among the 2 subplots now instead of the 3, because we're only interested in 2 columns worth of data. Note there isn't a row property, there's only the columns property. Okay, so that's all I wanted to show you here. I know we covered a lot of different stuff. Pretty much all of the functionality that a series have, a data frame has as well. Data frames will have extra stuff. Just remember that you need to specify which axis you want, depending on whether you want the row-specific properties or the column-specific properties. Otherwise, definitely play around with this, explore a bit. There are tons more properties and functions out there. I just wanted to show you some of the maybe more commonly used ones. Okay, so in the next section, we're going to be working on modifying data frames. This could be like modifying individual elements, how the data frame is structured, etc. So stay tuned for that. Thanks for watching, and see you guys in the next one.